AC samples translates atmospheric carbon dioxide concentrations into tangible sensory encounters, materializing the otherwise imperceptible dynamics of climate change. AC samples integrate site-specific botanical specimens, ranging from common grasses and herbaceous plants to bryophytes, as bioindicators in its experimental ecological monitoring system. AC samples subjects its botanical specimens to controlled atmospheric environments with systematically elevated carbon dioxide concentrations, creating discrete zones of anthropogenic climate simulation. The AC samples autonomous vessels, integrating biosensors and microcontrollers, embody a techno-aesthetic investigation with a sober sculptural form. Through its calibrated sequence of atmospheric chambers, 280, 420, and 1,000 parts per million carbon dioxide, the installation compresses centuries of anthropogenic atmospheric transformation. The installation creates 3 parallel atmospheric chambers, each hosting identical botanical specimens under historically significant carbon dioxide concentrations, 280 parts per million, mirroring pre-industrial atmospheric conditions, 420 ppm, reflecting present-day levels, and 1,000 ppm, projected under the business-as-usual scenario for 2100. The pre-industrial atmospheric conditions of 280 ppm are biotechnologically maintained through a colony of Arthrospira platensis, spirulina, sustained within an automated microenvironment that regulates temperature, illumination cycles, and gas exchange. The project traces its conceptual lineage to Joseph Priestley's seminal 1774 work, Experiments and Observations on Different Kinds of Air, a pioneering investigation into atmospheric composition that led to both the discovery of oxygen and the invention of carbonated water. Echoing Priestley's proto-scientific exploration of invisible aerial substances, AC samples translates contemporary atmospheric perturbations into perceptible phenomena. Rendering legible the otherwise imperceptible transformations of our aerial environment. The dual valence of AC in the title operates as both signifier and metaphor. While here denoting atmospheric condition, it deliberately evokes the ubiquitous air conditioning, a semantic slippage that mirrors their material entanglement. This technological ecological feedback loop manifests as rising global temperatures drive the proliferation of cooling systems, whose intensive energy demands and resource consumption further amplify the very atmospheric conditions they attempt to mediate. Atmospheric entropy. AC samples interrogates the anthropogenic carbon dioxide cascade, a geologic-scale intervention that reconfigures planetary metabolism. The progressive atmospheric carbonization represents an unprecedented temporal disjuncture where human industrial activity inscribes multi-centennial transformations into Earth's climatic architecture, with potential atmospheric recovery spanning millennia beyond immediate human temporal scales.